Did you know that the chocolate you might be snacking on right now is actually radioactive?
Wait, really? The chocolate?
Yeah, it actually is.
Yeah.
Like if you've got any Easter treats lying around, maybe some hot cross buns or chocolate eggs, there are trace amounts of natural radiation just sitting right there in your kitchen.
That is wild. I mean, I guess before anyone throws out their stash, they should probably know that we are all basically swimming in this sea of invisible energy all the time.
Exactly. And today we are taking a deep dive into exactly who is watching that invisible sea. We're going to get into why the sudden explosion of 5G is forcing cities to completely change how they prove that we're actually safe.
It's such a great starting point, though. It completely reorients how we think about our environment. We tend to view radiation as this unnatural, terrifying force, right?
Oh, totally.
But in reality, it's just this constant, invisible infrastructure of the natural world.
Right. And to figure out how we navigate that, we've got a fantastic stack of sources today. We are pulling from the official public guidance of ARANSA.
Ah, right. The Australian Radiation Protection and Nuclear Safety Agency.
That's the one. We also have these technical white papers from TMG Test Equipment, and we're digging straight into the system data sheets for a Wavecontrol's continuous EMF monitoring software.
Which is great because it gives us the perfect spectrum of information. We are looking at the absolute baseline of how a government monitors everyday radiation and then zooming all the way into the cutting edge of modern telecommunications.
Exactly. So our mission for this deep dive is to uncover how this invisible infrastructure is tracked, why the old legacy methods of measuring it are basically falling apart under the weight of 5G, and how a new philosophy of radical transparency is stepping in to save public trust.
I love that phrase, radical transparency.
Yeah, it's fascinating. But okay, let's unpack this Easter chocolate thing first. It is slightly radioactive, sure, but AirPanza assures us it poses absolutely zero risk to your health.
Right, not at all.
So if they are monitoring our snacks, what else are they doing out there?
Well, you can think of them as essentially the country's invisible weather service. Our PANZA is the primary authority in Australia regulating both ionizing and non-ionizing radiation.
Okay, meaning they cover everything from what, the sun?
Yeah, exactly. They track everything from the ultraviolet rays of the sun and your everyday residential power lines, all the way up to highly sensitive radioactive waste disposal and, like, nuclear-powered vessel visit planning.
Wait, before we go further, we need to clarify that distinction. I see those two terms thrown around a lot in these safety debates. What is the actual physical difference between ionizing and non-ionizing radiation?
It basically fundamentally comes down to energy and what that energy does to an atom. So ionizing radiation,
That's the heavy stuff, right?
yeah, think X-rays, gamma rays, or nuclear fallout, that stuff packs enough physical energy to literally strip electrons away from atoms.
Wow.
Yeah, it alters cellular structures. It can directly damage human DNA.
Okay, so that is the stuff that causes cancer. Stuff we wear those heavy lead aprons for at the dentist.
Precisely. But non-ionizing radiation, on the other hand, just does not have the energy to strip electrons or alter your DNA at all.
So what falls under that umbrella?
We're talking about radio waves, microwaves, Bluetooth, visible light, and of course, 5G cellular signals.
Okay, so it's a completely different mechanism.
Exactly. When non-ionizing radiation interacts with your body, it doesn't break chemical bonds. Its primary mechanism of interaction is thermal.
Thermal. Like heat.
Yeah, it just creates a tiny bit of heat, much like how a microwave oven heats your food, but obviously at a fraction of the power level.
That makes our Pansa's scope just massive then. Because looking at their public guidance, they have this whole system called RAD-MAPAS for environmental monitoring.
Right, which covers the broad strokes.
But they also get incredibly granular with the dangerous stuff, the ionizing side. They run a personal radiation monitoring service specifically for workers in medical, dental, mining, and industrial fields.
Because in those specific environments, cumulative exposure is the real danger. If you are a radiographer or working in radiation oncology, you are dealing with high-energy ionizing radiation every single day.
So they have to track it over a lifetime.
Exactly. Our PANZA monitors that through their Australian clinical dosimetry service. They track the exact precise amount of ionizing radiation a specific worker absorbs to ensure they remain safe over an entire career.
Which makes total sense.
Yeah.
We tightly regulate and track the heavy DNA-altering stuff in industrial settings. But let me play devil's advocate here for a second, because this is where the public debate gets incredibly heated.
Oh, for sure.
If our PANSA has firmly established that non-ionizing stuff, like 5G and EMF, is fundamentally incapable of altering our DNA and only produces negligible thermal effects, Why the sudden outrage?
It's a great question.
Why are local communities demanding such intense granular monitoring for neighborhood cell towers if the physics literally say it's harmless?
Well, what's fascinating here is that it's largely a matter of visual proximity and the sheer architectural shift of modern telecommunications.
What do you mean by architectural shift?
Think about how a 3G or 4G network was built. You had these massive, towering macro cell sites placed really far away, often out in industrial zones or on top of giant hills.
Right. They blasted lower frequency signals over huge geographic areas. They were completely out of sight, out of mind.
Exactly, but 5G changes the physical rules. 5G networks, especially the faster millimeter wave bands, use much higher frequencies.
And higher frequencies behave differently.
Yeah, those shorter wavelengths can carry massive amounts of data, which is why your phone can download a movie in seconds now. But they are terrible at traveling long distances. They get blocked by trees, heavy rain, and concrete buildings.
So to make the network actually function, telecom companies can't just build one giant tower on a hill anymore.
No, they have to build hundreds of smaller ones. The infrastructure is moving out of those hidden industrial zones and being bolted directly onto the street lamps right outside people's bedroom windows.
Wow. Yeah, the sheer density of the infrastructure is what is driving the community anxiety.
Exactly. People are suddenly living directly underneath this equipment, and it feels invasive.
And so we look at the primary safety framework in Australia, right? The RPS S1 standard set by ARPANSA. It outlines strict limits for human exposure to these radio frequency electromagnetic fields.
And the scientific community entirely agrees these limits are incredibly safe.
So why wouldn't telecom operators just hand the public the RPS S1 documentation and say, look, read the science, we're fine? Aren't these continuous monitors we're going to talk about just validating the paranoia?
You would think so, but no.
Why should an operator spend millions to measure something we already know isn't dangerous?
If we connect this to the bigger picture, operating in a vacuum of public trust is far, far more expensive than buying some sensors.
Oh, because of the pushback.
Exactly. When a community feels ignored or managed rather than informed, that anxiety morphs into immediate action. Telecom operators face massive project delays, organized community protests, and highly costly legal injunctions blocking the installation of new equipment.
So you basically cannot litigate your way into public trust using a 200-page physics white paper.
You really can't. You have to show them the math in real time. Which brings us to a massive flaw highlighted in the TMG test equipment white papers.
Right, the snapshot problem.
Yes. The legacy way telecoms used to prove compliance to a concerned neighborhood was essentially a snapshot. An engineer would literally drive out to the tower with a handheld survey meter, take a quick reading, write it on a clipboard, and submit a report.
Saying, hey, look, we are well below the RPANSA limit.
Right. But the public rightfully started questioning that methodology because wireless environments are not static. The 3 a.m. snapshot is the classic example of this flaw.
Here's where it gets really interesting. That part blew my mind. If you test a cell site at 3 in the morning, you are fundamentally misrepresenting the safety of that environment.
Think about the mechanism of how a cell tower draws power. A cell site does not broadcast at maximum capacity 24 hours a day. It scales its power output dynamically based on user demand.
Oh, so at 3 a.m., nobody in the neighborhood is actually using data.
Exactly. The network traffic is near zero, which means the electromagnetic field being generated by those antennas is at its absolute lowest point.
So the engineer takes a reading at the quietest possible moment and hands the city council a report declaring the site perfectly safe.
But then 5:00 p.m. hits. Everyone in the suburb gets home from work, they turn on their smart TVs, they start streaming high-definition video, playing online games, and jumping on video calls.
The data demand just skyrockets.
Yeah, and the base station ramps up its power output to handle that load. The EMF levels rise significantly. The 3 a.m. safety report is completely blind to that afternoon surge.
It is basically the equivalent of sending an acoustic engineer to measure the noise levels outside a really loud nightclub. But they do it at 10 in the morning on Tuesday.
That's a perfect analogy.
And then they hand the angry neighbors a certified document saying, what are you complaining about? It's perfectly quiet. It completely insults the intelligence of the public.
Which is why the snapshot method is effectively dead. If a single point-in-time test cannot capture the dynamic nature of a 5G network, the only acceptable technological fix is continuous 24/7 monitoring. You have to deploy a sensor swarm.
And this is where we dive into the Wavecontrol Control IoT hardware. I was looking at the sister data sheets for these things, and I was honestly expecting some massive intrusive radar dish.
Right, like a huge satellite.
Yeah, But they are incredibly compact, low-power devices. The documentation emphasizes that they are IP65 rated. I see that acronym on a lot of electronics these days, but what does an IP65 rating actually guarantee for a sensor sitting out in the wild?
So IP stands for ingress protection, which is an international standard defining how well an enclosure seals against the outside world. The first number, the 6, means it is completely dust-tight.
Okay, so no solid particles can get into the circuitry at all.
Right. And the second number, the 5, means it is protected against low-pressure water jets from literally any direction.
So it isn't just a cheap plastic cover. It is a sealed vault.
It has to be. If you are permanently mounting these across an entire suburb or a university campus, they have to survive extreme Australian UV radiation in the summer and torrential downpours in the winter, all without the internal calibration drifting.
Let's talk about that calibration, because you cannot just buy some generic RF meter off the internet, zip tie it to a telephone pole, and expect a local council to accept your data. The TMG papers are very strict about this. The sensors must have NETA traceable calibration.
Yes. NETA is the National Association of Testing Authorities here in Australia. If this data is going to be used to prove legal compliance with our PENSA limits, the instrument taking the measurement must be certified to an incredibly exacting national standard.
So it holds up in court.
Exactly. If a community group takes a telecom to court over a tower, and the telecom brings data from an uncalibrated, uncertified sensor, the judge will throw that data out entirely. It is legally meaningless.
That makes sense. The physical deployment of these calibrated sensors is where the real complex engineering comes in, though. You're trying to find what the engineers call the point of maximum exposure.
Which is much harder than it sounds.
Right. You have to calculate the tilt and the specific direction of the antennas. And reading the data sheets, there are two major physical pitfalls that can completely ruin a $10,000 monitoring setup: signal reflection and shadowing.
These are fantastic examples of how invisible radio waves behave exactly like light or sound waves in the physical world. Let's start with signal reflection. If an installer is, say, a bit lazy and mounts a continuous monitor too close to a metallic structure, say, a metal roof or a large HVAC unit, the radio frequency waves hit that metal and bounce back.
They reflect off of it.
Yes, and when they reflect, the incoming waves from the tower and the bouncing waves from the metal crash into each other. This creates constructive interference.
So they sort of multiply.
Basically, the waves compound and concentrate in that specific physical space, causing the sensor to register an artificially massive spike in EMF.
Oh, wow. So the system triggers a panic alarm. The telecom thinks they are violating federal law, but in reality, it's just an invisible echo chamber localized entirely around that one sensor.
Precisely. It's a false positive. Now, the second pitfall, shadowing, is the exact opposite and arguably much more dangerous for public trust.
How so?
This is when a sensor is mounted behind a dense structure, like a thick concrete pillar or a brick wall.
But wait, how much can a brick wall really stop a cell signal? I get service in my house.
Significantly more than you'd think, especially with 5G millimeter waves. Dense physical materials absorb and attenuate radio frequency energy. So if the sensor is sitting in the shadow of a building, the physical object is absorbing the brunt of the signal.
Oh, I see.
The sensor records incredibly low, beautifully safe EMF levels, but the public walking down the street on the other side of that building in the direct line of sight of the antenna is experiencing a much higher level of exposure.
You are capturing a completely false reality. You miss the actual street-level experience entirely. Have you ever considered how a building's shadow might actually hide a cell signal like that? It's wild.
It really is, which highlights why deploying these sensor swarms requires meticulous, highly trained site assessment. You can't just slap a sensor on a brick wall and call it a day.
Right.
You also need hardware that actually understands what it is listening to. The Monet IoT uses what are called frequency selective sensors.
Meaning they don't just measure all the random radio noise in the air, like it filters it.
Right. If you want to prove a specific 5G tower is safe, you need a sensor capable of isolating and measuring the exact millimeter wave or mid-band frequencies that specific carrier is broadcasting on, while completely ignoring the local police radios or, the AM radio station a few towns over.
Okay, so let's put this all together. You have these NATA-calibrated IP65 weatherproof sensors. They are placed with absolute mathematical precision to avoid shadows and reflections. And they are using low-power IoT networks to stream continuous EMF data back to a central server 24/7.
That's the setup, yeah.
What does the telecom operator actually do with that endless stream of data?
They automate their compliance. The software mechanics here completely change utility management. An engineer can program threshold alerts into the system backend.
Like tripwires.
Exactly. For example, they can set a hard rule if the EMF levels at the corner of Main Street ever reach just 50% of the Arm-Pantsa safety limit. The system triggers an immediate automated notification.
So the site manager gets a ping on their phone instantly.
They get an alert about a timeout, a sudden level spike, or even just a drop in the sensor's battery voltage. They move entirely from reactive complaint handling, waiting for a neighborhood to organize a protest, to proactive management.
They know a site is behaving abnormally before the public even senses an issue.
Exactly. It's a game changer for them.
That is fantastic for the engineers. But let's go back to the core problem we started with. Having a brilliant automated alert system pinging a site manager's phone solves the telecom's problem. It absolutely does not solve the angry resident's problem.
No, it doesn't.
The resident doesn't have the engineer's pager. If the data is locked away in a private corporate dashboard, the public is still totally in the dark.
And this is the critical final piece of the puzzle. This raises an important question about how we handle data. This is where we transition from purely technical monitoring into the philosophy of the modern smart city. You have to practice radical transparency.
So what does this all mean in practice? The tool they use to execute that is the Wavecontrol Control Centre, right?
Yes. It is a web-based application that essentially yanks all of that dense EMF data out of the private engineer spreadsheets and throws it onto a highly visible, public-facing interface.
Because you have to remember who the end user is here. The public does not want to read a technical spreadsheet measuring voltage per meter or microwatts per square centimeter.
Definitely not.
They just want the answer to one single question: is my street safe right now?
So the control center translates it visually. It integrates directly with Google Maps. You pull up the map of your suburb and you see all these little markers where the physical sensors are deployed on the light poles.
It's essentially a public fitness tracker for your neighborhood's infrastructure.
I love that. Yes. But instead of raw numbers, the markers are color-coded based on how the local EMF levels compare to the strict Arm-Pantsa limits.
It acts just like a public decibel meter outside that loud nightclub we talked about.
Yeah.
Instead of residents calling the local council to complain and waiting a week for an inspector to take a static reading, anyone can just look at the map and see the reality in real time.
Exactly. A blue marker on the map might mean the EMF level is hovering between 0 and 1% of the allowable safety limit. A green marker might indicate 1 to 2%.
It takes rigorous, NETA-calibrated, legally defensible scientific data and turns it into a universally readable language. Colors on a map.
It's brilliant.
You can click on your street corner, zoom in, and literally watch the 24-hour sliding averages of the invisible energy in your own neighborhood.
Think about the immense empowerment this offers to local governments. Historically, a city council would be caught in this miserable middle ground between terrified residents and massive, heavily lawyered telecom operators.
Right, because the council didn't have the technical expertise to interpret the 3 a.m. snapshot reports, but they still had to answer to the voters.
Now, that entire dynamic is neutralized. When a resident calls the council deeply concerned about a new 5G small cell being installed outside their local park, the council doesn't have to argue physics over the phone.
They just hand them a URL.
Exactly. They point them to an official, live, open book data source. The resident can open their web browser at 6:00 p.m. on a Friday, peak Netflix hours when the network traffic is absolutely surging, and see with their own eyes that the EMF levels remain a tiny, negligible fraction of what Arm-Pantsa considers the safe limit.
It instantly de-escalates the tension by removing the mystery. And we aren't just talking about a theoretical white paper concept here. This radical transparency is actually operational right now in Australia.
Oh, yes.
TMG Test Equipment has set up a permanent, live, Monet-MM IoT demo unit right outside their head office in Clayton, South Victoria.
It serves as a working physical proof of concept. They didn't bury the sensor data behind a corporate firewall. They built a publicly accessible portal.
Anyone can look at it.
Anyone listening right now, a community organizer, an infrastructure engineer, a curious student, can log on and watch exactly how the electromagnetic environment of an industrial suburban area fluctuates hour by hour.
It proves the plug-and-play capability actually works. It proves that you can mount a continuous monitor in the harsh Australian weather, have it quietly analyze the invisible waves bouncing around the buildings, and broadcast that safety data to the world without the sky falling.
And that level of transparency has to become the foundational pillar of the modern smart city. We are building urban environments that are incredibly data-driven, but, all the data in the world is entirely useless if it doesn't foster community engagement and trust.
Absolutely.
Proving that our digital infrastructure is safe by doing it openly and continuously is the absolute only way to secure long-term public support for these technological leaps.
It really is an incredible journey when you step back and trace the evolution of how we handle this invisible world. We started by looking at baseline natural radiation, the fact that the Easter chocolate in your pantry is quietly, harmlessly emitting energy, all monitored by the overarching eye of our panza.
Right. And then we moved to the realization that as telecommunications evolved from distant towers to high-density 5G networks, the old legacy methods of single-point snapshot testing fundamentally failed to capture the dynamic reality of how these networks actually operate.
And we ended up in the era of radical transparency, where NATA-calibrated weatherproof sensor swarms are mapping the physical behavior of electromagnetic fields, avoiding the pitfalls of signal reflection and shadowing, and broadcasting live, color-coded safety data straight onto public maps.
It's a huge leap forward.
So the next time you see a new 5G tower going up in your neighborhood, or you spot one of those strange little white domes mounted on a municipal street lamp, you will understand the massive 24/7 invisible monitoring infrastructure that is quietly working to keep your smart city running safely.
It proves that transparency is the ultimate antidote to anxiety. When you illuminate the unknown, you replace fear with understanding.
You really do.
Yeah.
But it leaves me with one final thing to think about.
Yep.
If we are rapidly moving toward this highly advanced open book world where invisible electromagnetic fields are mapped live, color-coded, and available for anyone to scrutinize from their smartphone at any second of the day.
What?
Wait, no. At any second of the day, what other invisible environmental factors will we soon demand real-time transparency for?
Oh, that's a great point.
If we can perfectly map the invisible radio waves bouncing off a brick building, how long until the public expects that exact same real-time X-ray vision for the air we breathe, the water we drink, and the environments we walk through every single day?